sklearnmetrics, pairwise, paired distances. Description. The paired distances function calculates the distances between pairs of corresponding points in two arrays. It supports various distance metrics, allowing you to assess the dissimilarity between paired data points across different dimensions. Inputs. X a 2D array of shape n samples. N features representing the first set of data points. Each row corresponds to a data point, and each column represents a feature. Y a 2D array of shape n samples. N features representing the second set of data points. Each row should correspond to a data point paired with the corresponding row in X. Outputs. Distances a 1D array of shape n samples containing the pairwise distances between corresponding points in X and Y. Steps. For each pair of corresponding data points in X and Y, the function calculates the distance using the specified metric. The calculated distances are stored in the distances array. Metrics. Euclidean distance measures the straight line distance between two points in multidimensional space. Manhattan distance calculates the sum of absolute differences between corresponding coordinates of 2 points. Chebyshev distance determines the maximum absolute difference between corresponding coordinates of 2 points. Minkowski distance generalizes Euclidean and Manhattan distances with a parameter p, where p1 is Manhattan distance and p2 is Euclidean distance. Visualization plots. Scatter plot visualize the distribution of pairwise distances, highlighting clusters or outliers. Heat map represent the pairwise distances as a matrix, with color intensity indicating the distance magnitude. Fine-tune parameters. Metric string specifying the distance metric to use. Common options include Euclidean, Manhattan, Chebyshev, Minkowski, and others. P integer. Only used when metric Minkowski. Controlling the order of the Minkowski distance. Uncertainty methods. Bootstrapping resample the data with replacement and calculate distances on multiple bootstrap samples to estimate the uncertainty in the distances. Challenges and fixes. Challenge 1 handling missing values. Sample use case that resulted in challenge 1 if either X or Y has missing values. The calculation might fail or produce inaccurate results. Fixes to challenge 1. Impute missing values using methods like mean imputation, median imputation, or more sophisticated techniques like KNN imputation. Use a distance metric that can handle missing values, such as the Hamming distance. Challenge 2 choosing the appropriate metric. Sample use case that resulted in challenge 2 selecting an inappropriate metric can lead to misleading interpretations of distances and impact downstream analysis. Fixes to challenge 2. Understand the nature of your data and choose a metric that reflects the relevant notion of similarity or dissimilarity. Experiment with different metrics and assess the impact on the results. Consider domain expertise to guide metric selection.